In this video, we're going to review linear patterns. So our question here says, for the following pattern, and we have diagram 1, diagram 2, and diagram 3, it first asks us to complete a table of values. So we have a column for diagram and then the number of squares. So in diagram 1, there are 1, 2, 3, 4, 5, 6 squares. In diagram 2, there are 1, 2, 3, 4, 5, 6, 7, 8 squares. And then in diagram 3, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So I see in the table, I do need to do diagram 4 and 5, so I have choices. So option number 1, I could draw and follow the pattern. So I could draw out diagram 4 and diagram 5, or I could look to see what is happening with these numbers. Now, if I look at the diagrams, I see that from diagram 1 to diagram 2, it has 2 more blocks than diagram 1 did. Diagram 3 has 2 more blocks than diagram 2. So I'm assuming that the next diagram for diagram 4 should also have 2 more blocks. So I would think that it should have 12. And then the next one after that would have 14. Okay, part B says, is this pattern linear or nonlinear? So if something is linear, it makes a straight line. So the differences should be going up or down by the same amount every time. If it is nonlinear, then we would find that that is not the case. So I am going to take a look and calculate my differences. So on the diagram side, to get from 1 to 2, I added 1. To get from 2 to 3, I added 1. From 3 to 4, I added 1. From 4 to 5, I added 1. On the number of squares side, I noticed that the pattern was that we were adding 2 extra blocks every time. So here from 6 to 8, we added 2. From 8 to 10, we added 2. From 10 to 12, we added 2. And from 12 to 14, we added 2. So on the diagram side, we're going up by the same amount every time. On the number of squares side, we are going up by the same amount every time. So I would say that this pattern is linear. All right, part C says determine the initial value. Now the initial value is term 0. Or in this case, diagram 0. It's not diagram number 1, it'll be diagram 0. So looking at my table, I don't have diagram 0, so I need to try to work backwards to figure out what 0 would be. So I want to try to go backwards in my table to find term 0. I noticed that we were going up by 1 on this side every time, so here I'm just going back by 1 to get to term 0. So I'm going to go back on the other side by 2. So I would subtract 2 to go backwards here. So I would do 6 take away 2, which is 4. So my initial value would be 4. So my initial value is 4. Okay, up next, and I should put a unit on it, it is 4 squares. All right, up next it asks for the rate of change. So the rate of change is how much we're going up or down by each time. So there's a formula for rate of change that we learned. We said rate of change is delta y over delta x. Delta y and delta x come from the differences on my table. So the first column should be x, and the second column should be y. So the changes or the differences on the x side, that's delta x, and the changes or the differences on my y side is my delta y. So delta y, we were going up 2. Delta x, we were going up 1. So this is 2 divided by 1. 2 divides nicely by 1. It just equals 2. So we are going up 2 squares per diagram. So for every diagram we go up, the number of squares goes up by 2. All right, the next part of the question says write an equation for the pattern where S is the number of squares and N is the diagram number. So I would start with S equals, so the number of squares equals. We usually start with our initial value. So we start at 4 squares, and then to that we are adding an additional 2 squares every time. But I'm not just adding the 2 squares once, we're doing it 2 times or 5 times or 10 times, depending on what the diagram number is. So I would do 2 times n. So S equals 4 plus 2 times n. Or you could do S equals 2n plus 4, right? Where we put the initial value last, and then we put the rate of change first. The important thing is that the n, the variable, needs to stay with the rate of change. Okay, our last 2 questions involve doing a little bit of calculating. So it says, using your equation, calculate the number of squares in the 20th diagram. So our diagram, according to our formula here, is n. So we're looking at n being 20 because we want the 20th diagram. And it did specify that it wants us to use our equation. So I'm going to take my equation. So S equals 4 plus 2n. And everywhere I see an n, I'm going to put in 20. So I'm going to say S, the number of squares, is 4 plus 2 times 20. I need to multiply before I add according to order of operations. So I'm going to get 4 plus 2 times 20 is 40. And then 4 plus 40 is 44. Just need to finish that off with a little sentence that says, therefore, so calculate the number of squares in the 20th diagram. I'm going to say there will be 44 squares. All right, our last one says, using your equation, calculate which diagram would have 302 squares. So this isn't talking about the 302nd diagram. This wants to know which diagram has 302 squares. So this time S is going to be the number, so 302. So I'm going to take my equation, and everywhere I see an S, I'm going to put in 302. So I'm going to say S equals 4 plus 2n. Put 302 in for S. And then I need to try to solve for n. Now to solve for n, I can leave it on the right-hand side and just move everything over to the other side. But I find some people do better if the n is on the left. So I'm going to trade the 2 sides. And I do like having the term with the n first. So I would do 2n plus 4. It's okay to switch the order as long as you leave the sign in front of the term with the term. So this is a positive 2n and then a positive 4 equals 302. So in order to solve for n, I would like to move the plus 4 by subtracting 4 from both sides. So I will get 2n equals 302, take away 4 is 298. And then I'm going to use my calculator to help me with this division. I would divide both sides by 2. 298 divided by 2 is 149. So using your equation, calculate which diagram would have 302 squares. I'm going to say, therefore, it is diagram number 149. Okay, and that's it for our line review for today.